Hello and welcome to the latest Innova Systems webinar, an introduction to electrical routing. In this webcast we will look at manually creating a route using standard cables and using a from-to list. We will also look at how you can create routing components. So I have the sensor assembly open and we're going to create a route. If you look in the task pane, I have all my electrical routing components saved there within the design library, i.e. my connectors and clips. Now I'm going to start a route by dragging a connector 3-pin male into my assembly. Now you'll notice as I drag it in, it snaps into place. This is due to the mate references that have been saved with the part. As we drop it into the assembly, the route property manager launches down the left hand side. Now this is basically prompting us to give our assembly a name, define which template we want to use, define whether it's a harness or cable and wire, and define a nominal outer diameter. We can also add a covering at this stage, but I'm not going to. So if we just hit the green tick, at this stage we will see a stub appear coming out of my connector. This is essentially the start of the cable. Now I'm also at this stage going to add in a second connector, so a 3-pin female, and again you can see that just snaps into place due to the mate references that are saved within the part. Now the idea here is that we join these two stubs together with sketch geometry. So you can use lines, arcs or splines, or alternatively we can use the auto route tool that is launched in the property manager here. That will just allow us to select the endpoint of our stubs and connect them together. If we were working on pipework, that perhaps would be an orthogonal route instead. Okay, now our route, as you can see at the moment, is passing over existing geometry and we need to reposition the spline. So we can do that by manipulating the spline on the screen, i.e. grabbing the drag handles, adding additional spline points and dragging those about. Or alternatively we can use clips to help position our spline. So the clip, again, I'm just going to drag and drop in from the design library. So we'll place one there and confirm the coincident mate, and then just one around the corner about there. Okay, now with this first clip, all I'm going to do is just rotate that around, something like that. Now if I relaunch the auto route tool, I can select my spline, select the axis of the clip, and you can see it will route my spline through that clip axis, like so. Okay, now I'm also going to add another male and female connector to this route. So again, we'll just drag and drop that in from the design library, get it to snap into place automatically. We see the stub appear. And we'll just connect these together now. So I'll relaunch auto route, connect this first stub to the point at the beginning of the clip, and on this end it's slightly more difficult because we have nowhere along that spline that we can connect this stub to. So all we'll do is right click on the spline, split the route, that launches a split entities tool, and we can split the spline anywhere along its length. So I'm going to click there and then just auto route the endpoint of the stub to the split point. Okay, so at this stage the actual routing geometry is complete, but we have no information within the route of what wires are used and where they go from and to, so we'll look at doing that. To do that we just simply select Edit Wires, and that will launch the Edit Wires property manager. We have this Add Wires button there, which will allow us to access our wire library. So this is something that you can create and customize yourself. So within here I've just added some 20 gauge wires. So I'm going to choose a red and a black, and I'm going to add 2 of each. So as I add them, they appear in this from to list box here, and they show with errors next to them. And if we ask what's wrong, it tells us that the wire is not routed. So it knows we want to use those wires, but it doesn't know where they go from to at the moment. So with 1 black and 1 red, what I'm going to do is just select a path and say that it runs along that path like so. Press OK, and you can see at that stage the warnings disappear. You can also define where it runs from to by selecting the components. Okay, now also within here, when we create our connectors, we define how many pins the connectors have. And we need to tell SolidWorks which wire connects to which pin in the connector component. So with the blacks, I'm just going to say that they connect to pin 1. And with the reds, I'll say they connect to pin 2. Press OK. Okay, we'll exit the sketch now, and that's our first root subassembly complete. Now we're going to look at creating a manufacturing drawing for that root subassembly. So here's our root subassembly, and first thing I'm going to do is flatten the root out. So we can come into flatten root here, and we have a couple of options of how we flatten. So annotation within flatten type will allow us to create an unscaled schematic, whereas manufacture will create a drawing to scale from the flattened root. With your connectors, you can display the 3D models, or you can use drawing connector blocks. So these would be predefined 2D sketches that you could use to show for the connectors. You can also at this stage include drawing options, which will allow you to create a drawing where you pick your template, pick what BOM you want to use, pick a template for your cut list, pick a connector table template as well, and define whether you want to auto balloon as well. So as we press OK, that will flatten the root on the screen, and it will create our drawing on the template that we asked it to. So if we zoom up to the connector tables first, you can see that next to each connector a table is placed, and it tells us on the connector which wire is connected to which pin. We also have circuit summary, which gives us the part name of our wire, what the wire ID is, the colour, the overall length, and where it runs from and where it goes to. And finally we have a bill of materials, which includes the 4 connectors that we've added to the root and the wire, and you can see that it totals up the total length of one particular wire within the bill of materials, which is good for purchasing. Okay, we'll close that, and I'll not worry about saving it. And we'll move on to standard cables. So standard cables can be good if you purchase or need to keep a cable of specific length. In this instance, what I want to do is to connect those 2 highlighted components with a Cat5 cable. Now we buy these in, and we buy them in at 300mm long. So rather than dragging in the Cat5 cable from the design library as we did earlier on, or similar to what we did earlier on, what we can do is launch something called standard cables. Now standard cables are driven by an Excel spreadsheet, and I'll just launch that spreadsheet. So this is what the standard cable spreadsheet looks like. This is fully customizable, so you can change it to suit your company practices. Specifically here, we're looking at this Cat5 300mm cable. So we tell it the route type, we then give it a description. We then have references. So connector 1 in this case is an RJ45 male part. The config that we're going to use is the default configuration, and that is going to connector 2. Again, it's the same part, the RJ45 male. Again, it's the default configuration. The length of it is 0.3 meters and the diameter of it is 0.005 meters. Okay, so let's have a look at how that works in standard cables in SolidWorks. Okay, to launch standard cables, we go to Routing Electrical Standard Cables. It's referenced in the Excel spreadsheet that we looked at earlier. From this drop down, we can pick the Cat5 cable 300mm long, and it displays here everything that was in the Excel spreadsheet file. So the parts that we use in the reference, the configuration, the length, the diameter is all here. And this can be changed at this stage as well. So if you are using a standard cable, which you might not have defined, it can be based on another cable, and you can just come in and change your options here. As I press OK, it will launch the Insert Components dialog, and our connectors will be listed in the part or assembly to insert with their reference names. So connector 1 is our RJ45 component, and we can just place it into our assembly like so. We'll place the other one in, and we're ready to start routing. So you'll notice this time that there's no need to auto route with this cable because it's connected already. The length of the cable that it's connected with is 300mm long. We have some options of where we position this, but if I just drag that out of the way, you can see that it will snap back to an original position. This is because it's maintaining that 300mm length. If we want, we can again just position this a little bit better with a clip. And then just simply auto route through that clip. Like so. We may also at this stage want to define a covering, so we can come up to this covering option here, and this again just uses a default library which you can customize yourself, and that consists of your various covering types, exactly what you want to use. So in this case we'll go for a 1/2 inch yellow tape, and then we'll apply it to that segment there. Press OK, and that covering will then come through in our bill of materials later on. Okay, so there's our Cat5 cable generated. The next thing we're going to look at is a from-to list. So again, a from-to list is defined in Excel. So if we just go ahead and open the from-to list. So this is what our from-to list looks like. It's completely customizable and relatively straightforward to create. Within here we define a identifier for the wire, the part number of the wire or cable that's being used, the reference names for the components, the pin number to which the wire is connected, the part number of the connector, the reference name for the second component, the pin to which the wire is connected, and lastly the part number of that second component. So for instance, within here we have a J1 component, which is the socket 6 pin, and that is going to 3 different plugs defined by 3 different references, so J3, J5 and J4. Okay, so if we have a look at that in action, To launch it, we go to start by from to. Again, we give the subassembly of the root a name. We define the Excel file that we're using, and we press OK. Okay, so that launches insert components, and we're just free to now place our connectors into the root assembly. So again, we're just going to make these in place using the make references that are saved in the part. We'll then be asked to define our root properties, so I'll just accept the defaults there. And because it's using a from to list, it knows how the wires are connected. And you'll notice that guidelines are placed down into the sketch to give you an indication of how the wires are connected. Now you can make use of these guidelines. So for instance here I'm just going to group select those there, and I'm going to merge them together to form a root, like so. At the other end, I'm just going to use the auto root tool and route them through the clip. So we'll go from here through our various clip axes. Till we get exactly what we want. Okay, so now that root sub-assembly is done, we'll have a look at creating a manufacturing drawing for that. Okay, so again we'll go to flatten root, but this time we'll have a look at the manufacturer options. We'll just leave everything as default there, and you can see that it creates a root for us based on the shape of the existing root. Now we have some controls to change the way this is displayed. So for instance here, I'm just going to right click on the root, go to edit flatten root, and I can apply bends in either direction. And perhaps I want to separate these connectors out so it's a bit clearer. Until you get exactly what you want. From there we can create an engineering drawing in the exact same way that we did before, and all the wire info and bill of materials will come through exactly the same as they did before. The last thing that we're going to look at here is how we can create our own routing components. So they do require some special geometries, but we have a really nice tool to guide us through this process. So we're going to open this clip and we're going to look at how we can make it a routing component. So if we go into routing tools, we can launch the routing library manager. Now within here we have something called the routing component wizard, and that will just walk us through the process of creating routing components. So it asks us first off what type of route this is going to be used for. In this case it's electrical. What is it? We're going to select clips, and then it tells us that it needs 2 R points. So it gives us a little indication in this image of where those R points should be, and because it's blue it means that these points are optional, present in the component. So all we do is we click on add. Now I have a couple of reference sketches in my part which I'm just going to show, and they are going to be used to help me create my R points. So I'll just come in and add my second. And you can see at this stage it turns green and it lets me know that I'm ready to move on to the next section. So it then tells me that I need to define a clip axis and an axis of rotation, and again we get an image letting us know where those should be. So if we click on add, we're going to create a brand new one, and that just launches the axis tool, and we create our axis between our two R points. We're now going to add our axis of rotation. Again, that's going to be new, and that will launch the axis tool again, and this axis of rotation is going to be created between the top plane and our R point. And we then move on to the next section. So as we drag and drop this into our assembly, we want it to snap into place, and we want it to be concentric and coincident with the edge that's highlighted in the image. So if we select add, all we need to do here to get that to happen is select the common edge between the concentric and coincident faces that you would want, and that's it. Click on next, and it tells us that the part modeling is complete. We press next to continue, and quite often within routing components we generate lots of different configurations for the different harness or wire sizes. In this case we'll just leave it as one, but you could generate configurations using a design table. It just asks us to save away the routing component to our routing library. So at this stage we will just click finish, and that would be that section complete. Okay, so thank you very much for attending the webinar. We have some future webinars coming up as listed there, and please feel free to get in touch with us should you require any more details. Thank you very much.